Hello, and now we're going to take a look at the law of cosines. This is also from chapter 4, and it is homework number 3. The law of sines is also on this homework assignment, so if you go to the last two problems, those are going to be your two law of cosine problems. Let's go ahead and take a look and see when we're going to use the law of cosines. There are two specific situations where we use the law of cosines. First of all, it has to be a non-right triangle. Just like with the law of sines, we want to use a non-right triangle. If it's a right triangle, then we'll just use SOHCAHTOA. Then, if it is a non-right triangle, you need to have one of two very specific conditions. You either have to have two sides and the included angle, which means the angle that makes up those two sides, and then in that case, you have to be looking for the opposite side. Or if you're given all three sides, then you can find any of the angles that are missing. If you look down here at the formulas, this set of formulas talks about what you're going to do if you're looking for a missing side. This set of formulas is what you're going to do if you're looking for a missing angle. You might want to copy those down. So now let's take a look at an example and see how you actually use the law of cosines to solve a problem. So in this case, we're looking for a missing side, which is why we have the formulas that are listed over here, because we're looking for a missing side. So what I'm going to do first is I'm just going to label my triangle A, B, and C. It doesn't matter which one I label A, which one I label B, and which one C. So I'll just start here with A, here with B, here with C. Then remember, the side opposite is the small c. The side opposite of A is small a. The side opposite of B is small b. When I'm doing this formula, notice that I'm going to be looking for C. That means I'm going to use this bottom formula here. So it'll look something like this. X squared, because I'm looking for x, is equal to A squared plus B squared minus 2 times A times B times the cosine of my angle C. Now, it doesn't matter which one you call A, B, and C at the beginning, because you can just use any of these formulas so that you're finding the correct variable. Now, when you do this, I would strongly encourage you to put all of this in your calculator at once. Don't try splitting it up and doing it in parts. If you put that on your calculator all at once, you should end up with x squared equals 2684.0639 something. Then to solve, you're going to have to do the square root of both sides, and the square root of that ends up being 51.81 when rounded to the nearest hundredth. And the last example we're going to do is going to be finding an angle. Just like when we're finding a side, I'm going to start off by labeling it using A, B, and C. So I'm going to call this side A, I'll call that angle A, this angle B, and this angle C, which means this side is little c, this side is little a, and this side over here is little b. Since I'm trying to find angle A, because that's where my x is, that means I'm going to use this top equation here. So it'll look something like this. The cosine of A is equal to B squared plus C squared minus A squared over 2 times B times C. Now, unlike the one we just did where I said you should do it in your calculator all at once, when you're doing this one, it's much easier to do the top in your calculator, then do the bottom in your calculator, and then put it all together. So we have the cosine of A is equal to 12400 over 22800. Now, to solve for A, or to solve for that angle x, what we need to do is do the inverse cosine. So we do the inverse cosine of 12400 divided by 22800. And when you put that in your calculator, you should end up with 57.05 degrees when rounded to the nearest hundredth. So x equals 57.05 degrees. Well, I hope that video was helpful, and good luck.